Hello.
Hello.
Welcome, Wassim.
Thank you for having me.
Last but not least,
Oh, okay.
Professor Jabi.
Jabi with a J.
Jabi, sorry for that. Sorry for that.
That's all right.
Yeah, so yeah, really happy that you are here, closing off room one tonight. Where are you at the moment, Wassim?
I'm in Cardiff in the UK, in
In
Wales.
Cardiff.
Yes.
Okay.
All right. So this is all kind of a new environment, but I guess
Yeah.
can the audience see? Can you see the screen? Like, is it shared?
When you yeah,
Here
now
we
we're
go.
seeing your screen, Wassim.
Yeah.
Oh, fantastic. Okay. Great. Right. Does it is okay? So it does go full screen. Fantastic.
Yeah.
Okay, good. So I'll get started because we have little time here. Welcome everyone. My name is Wassim Jabi. I am a professor of computational methods in architecture at the Welsh School of Architecture, Cardiff University. I am also the module leader the program leader, not the module leader, the program leader for an MSc, a Masters of Science in Computational Methods in architecture. So if anybody is interested in doing a master's in that area, please reach out and send me an email. Today, I'm going to be talking about how I integrated a piece of software that we've been working on for a long time called Topologic with VIKTOR, as well as using OpenStudio and Energy Plus for energy analysis. And we will show you how we implemented it on a very scalable solution. I have to preempt all of this by saying, first of all, I'm not an engineer. I'm an architect in training. And second of all, I'm not a computer scientist. I'm a hobbyist, even though I've been programming and building my own software for maybe close to 30 years now, but I still consider myself an amateur. So I wanted to share with you an experience of somebody, as I said, who's not a professional software developer, kind of getting introduced to VIKTOR, working their way through the online tutorials and the references and all of that, and trying it out, and then reaching out to the wonderful team at VIKTOR that was able to help me launch it. And I launched a few apps, and they ended up being on their gallery. And one of them now is still active, and that's the one I'm going to be talking about today, which is called EnergyViz. But before we get to EnergyViz, I want to tell you what Topologic is and where it came from. So let's see if this is going to work. Here we go. Right. So first of all, just to acknowledge the team, because this work is never done by one person. Topologic came out of a research project that was funded by the Leverhulme Trust from 2016 to 2019. And it included a team from Cardiff University, like Simon, Ekaterina, and Nicholas, and in collaboration with UCL, the Bergman School of Architecture in London. This was represented by Professor Robert Aish, who actually originated some of the early work on the basics of Topologic, which is based on something called Non-Manifold topology, which I will explain in a second. But what we told the Leverhulme Trust in our proposal, we explained to them the promise and the problem with building information modeling. And obviously, BIM is very useful, and you can have a lot of detailed information that allows stakeholders to collaborate. However, as we all know who have dealt with BIM data is often incomplete, it's unstructured, it's sometimes unconnected, it's sometimes ad hoc in the sense that it doesn't, it's always adhere to standards, and you cannot rely sometimes on it to always adhere to standards. That's really tough. It all depends on who modeled what software they used, what is even the corporate culture, what they are interested in and not interested in, and that we found to be very problematic. The other thing is that BIM was supposed to be about information modeling, not just building information modeling. And what I mean by information modeling is how you structure the information and how do you communicate it. There is no sometimes standard way of doing a proper schema, a proper standard for the information and how it's structured. You need to find plugins, you need to find translators sometimes, and it becomes really, really difficult and prone to a lot of errors and a lot of data loss. So we wanted to address all of this But we also wanted to acknowledge that we're not going to be able to compete and do something at the BIM stage. We want to do something at the pre-BIM stage, especially for architects and designers, so that the models that they are creating, they can get a lot of value out of before complexity kind of sets in. So the proposal was about redefining and augmenting BIM using three things: geometry, topology, and information. And you're going to hear me talk about these things a bit later. So this kind of triad of geometry, topology, and information is what makes Topologic really powerful. So we want to represent buildings as smart and consistent material, topological, informational, and temporal graphs. So there is this idea of a graph, which is made out of nodes and edges. And that graph can be mined for insights and used for analysis and for generative design. So what you are seeing on the right side is work that we have been doing for several years now with a company in Germany, in Dresden, called Ipro Consult. And what they have done is, with my collaboration, is take conceptual models out of a software called TestFit, which was invented in the US, in Texas, and then analyze it through Topologic, do a lot of analysis on it, and then automatically convert it to Revit model, to BIM models, just through the Topologic scripts. And that was really powerful because you can iterate a lot on the conceptual models, analyze them before you start, creating BIM models that are very complex to analyze. You will see in the lower side of the image this kind of light-colored strings, like almost like a spider web. That is the dual graph. That is the graph that is holding the information of that building and holding also the topological relationship, the adjacency relationship between the spaces or between the surfaces, whatever you want, you can represent, and it saves it all in a very comprehensive graph, and you can save that to graph databases like Neo4j, for example. And that's also something that Topologic can do. So the methodology that we follow, and especially in this project, was to design a succinct but semantically rich conceptual model. So we kind of balance a lower geometrical complexity with higher topology information and higher semantic information as well. And then we would like to analyze these models. We analyze them using, and today we're going to talk about energy analysis, but you can analyze structure, you can analyze spatial relationships, many things that have been used with Topologic in order to analyze your conceptual model. And that is to ensure quality, efficiency, sustainability, and value before, as I said, before you invest in converting it into a BIM model. And then the last step, once you are happy and you have iterated many times on that analysis, you can automatically and intelligently convert it to a fully detailed BIM model, and that is done by software rather than by humans. And that's really an important point. I have always advocated that as humans, as designers, we shouldn't be spending our time placing chairs in a conference room or placing windows on the facade. If we have a good set of rules and maybe experience, AI systems now can do that really easily. So again, the use case scenarios that we would like to show today, as I already mentioned, the project with Ipro Consult, they implemented it on a real project, on a student housing project. That's a 20 million euro project. And they used it to optimize the shape of the building. They used it to categorize the student apartments into different categories, etc. So they really put, they managed to, benefit a lot from the use of Topologic. The other use case scenario is in an open source environment in Blender, simply because also Topologic is open source and free to use. There are no, cost to using it. You can just download it from pip install or from GitHub and use it. This is the work of Bruno Possel, who has designed a piece of software called Homemaker that runs within Blender. And Topologic runs also within Blender if you would like, even though it's an independent Python library, but you can also run it within Blender or Dynamo or Grasshopper. And what he does with that is that he takes a cell, which is a topologic cell, and he slices it with planes, with surfaces, topologic faces. And with one click of a button, it converts it into a fully ISO standard IFC file. All the windows are there, all the details are in there, the doors, even the cornices, and even it has an embedded energy model inside of the IFC file. And that can be developed further using another software called Blender BIM, which runs within Blender for IFC, for native IFC manipulation and editing. So really, really powerful. The other concept I want to talk about is this idea of complexity last, not first. So what we are seeing a lot in our field is that people jump into making Revit models. They put as much detail, as much information, thinking that more is better in a way. And what we found out from our research is that if you would like to do some kind of analysis, like egress, like vision, like for example, to see whether the nurse station can see the doors of the patient rooms, this kind of information, this heavy information, almost stands in your way. You actually need to peel it away. You don't need it. Not only do you not need it, it actually hinders your analysis. So you need to remove it in order to do the analysis. What you need is geometrically simple but topologically rigorous models in order to do your analysis. And then you can use that as a skeleton in order to intelligently build the remainder of the building fabric. One of the dangers of talking about Topologic in a very short amount of time, as we have today, and I can see already I'm 14 minutes in, that people think, oh, it only does energy analysis, or it only does blockchain, or only does homemaker or Sverjock stuff. Topologic is very large, and it's a software library rather than a piece of software or a plugin. So you can use it to build on it whatever you would like that uses topology and geometry. This is some of the systems and platforms that we have integrated it with. Obviously, VIKTOR as well, IFC, Blender, Rhino, Revit, Pollination, Energy Plus, all of those are things that we have implemented, as well as, of course, machine learning in these days. You know, we cannot do anything without AI and machine learning. So graph machine learning is absolutely part and parcel of Topologic. But going back to what Topologic is and how it differs from a normal 3D modeling environment, in normal modeling environments that based on solids, for example, as you can see here, solids, if you look at on the cube on the left and you imagine yourself being that point that the arrow is pointing at, and you look at your sets, you see on one side, you see the inside of the cube, and on the other side, you see the outside of the cube. And those gives you two sets, and that's called two manifolds. What Topologic does is that it represents objects with multiple manifolds, with interior subdivisions. So if you are a point, if now you're looking at the one on the right side, and you are a point on top of it where that arrow is pointing, you actually look around and you see 5 sets. You see the 4 little cubes on top and the outside world. That's the 5th set. So that is called an N-manifold. So that is a non-manifold. So this idea of non-manifold is very compatible with energy analysis, because all you need in types of energy analysis is to actually look at how things are connected, or what surfaces kind of separate spaces. And that becomes really important. So we wrote an interface from Topologic that talks to OpenStudio using the OpenStudio API that obviously runs Energy Plus simulations, and we get the data back and we present it as color coding of the 3D model, all automatically done. And I will show you. I'll show you that. So yeah, I won't spend a lot of time on this, but basically these are the kinds of things that Topologic is really good at. Simplified geometry. A graph that you can see in the middle here is automatically generated. Every space gets a vertex, and the dictionaries and information that is saved in the space automatically get transferred into the vertices. And once you have a graph, you can find shortest distances, you can traverse it, you can use graph theory to analyze it. All of that is available. And once you get that information and those metrics, you can map them using color coding back onto your 3D model to get really nice visualization of your analysis. So you can decompose an object into sub-objects. That's called decompositional topology. You can ask a certain object what larger objects use it. So that is kind of climbing up the tree. We call it compositional topology. So I can ask a vertex, you know, what faces use you? Or I can ask an edge, what 2 faces use you, or what 2 cells use you, or etc. So you can climb up that tree. That topology is always available to you, and you don't have to do extra work to get it. You can just ask for an API call to get that. And the graphs are very powerful and very customizable. So not only do I go from room to room, I can ask it, let's say, to connect to the windows or to the ceiling or to even to a couch or a table inside the room, to the contents of a space. And that means you can have a much richer set of graphs that you can then analyze. So in this case, I have this building. We call it a cell complex because it's a complex of rooms, of cells. And I'm picking a cell randomly. Basically, that's the red cube that you see there, the red prism. And then I'm asking it to give me its neighbors. And it immediately gives me a list of cells that are neighboring it. And that gives you the ability to do all sorts of analysis. So getting to what I did with Topologic and with VIKTOR. So basically, we know that VIKTOR supports Plotly and supports Python. So that was like immediately an easy win for me because we are Python based and we use Plotly for visualization anyway. But we run it in a Jupyter notebook. So all it took really is to learn how to create an interface and then how to deploy Topologic to their server so that it can call it. Topologic Pi is pip installable, so it was very easy to do that by following their tutorial. But we took it a step further because we knew that we would like to scale things up in the future. And we took advantage of their remote worker capability. So basically, we created a server here in Cardiff University. It is a private server for us, so all the information is secure. We can lock it down as much as we want. And on that server in Cardiff University, that's what you see on the right side. We installed Topologic Pi, obviously, and with it we installed OpenStudio Energy Plus and Plotly, and we installed a small program which is their remote worker that kind of accepts jobs from VIKTOR. And then we had the interface done in an app called EnergyViz that we uploaded to the VIKTOR platform, and we ran it. And basically, what it does, and I'll show it to you running, like a video of it running. Basically, you give it an OBJ file, and it gives you back your energy analysis as a color-coded 3D model. So very quickly, that's what you would need as an input. Just a solid model, not even segmented if you don't want it segmented, because it will segment it for you. It will come up with the floors for you. So just an OBJ file, which is a solid model, a massive model. And then you upload that OBJ file. As you can see here, this is now the VIKTOR interface. I'm uploading an OBJ file to it. And then the sliders are basically window-to-wall ratio. So this is really, at this point, a proof of concept type of application. So it actually adds windows to the exterior faces. It can recognize exterior from interior walls and will do that. And once it's done, once you've uploaded everything and you've set all your sliders for the window-to-wall ratio, you simply send it, and after a few minutes, obviously energy analysis takes about maybe, for this building, maybe 5 to 8 minutes. It comes back and it has a color-coded 3D model that you can rotate. It has a scale. If you saw the tab on the right side, it has every space and the actual information. It actually brings back 3 Plotly figures, one for cooling loads, one for heating loads, and one for thermal comfort. So when you are switching, I took advantage of the caching that they have. They have a caching mechanism for the figure, so you don't have to go back and run another energy analysis. I ran 3 of them at the same time, and I bring them all back. So it's very quick to take a look at different metrics. And that's now the time not comfortable, basically. Right, so that is really it from me. I asked ChatGPT because everybody asked ChatGPT, so I asked it about topology because I think topology is really, really important. And it answered as follows. It said, topology delves into the intrinsic nature of spaces, emphasizing that the true depth of our world goes beyond surface-level shapes. It reveals the intricate web of connections and boundaries, serving as a reminder that reality is not solely defined by tangible forms, but also by the intricate interplay of relationships between them. And I think that's a really poetic of ChatGPT. They did a good job with it. Thank you. That's all really what I have to present today. I'm happy to take questions if there are any.
Thank you so much, Wassim. Really nice, really nice ending. Quite cool, that these large language models can come up with these kind of texts.
Yeah.
So one question I have related to this already is, how do you see this, these kind of new technologies like large language models? How do you see that also with the research and the work that you are doing combined with that? Do you see any opportunities there?
Yeah, definitely. Obviously, we started out, I mean, in terms of incorporating AI in Topologic and how we think about AI, we started, first of all, by a certain dissatisfaction with image recognition neural networks, simply because we found out that you really cannot tell what a building is, its typology, what's going on inside the building just from images. But there was a lot of research, a lot of people trying that, and kind of like from an image or from Google Street View, trying to understand what's going on with the building. So we decided that we really need to capture the graph of a building, and that means, unfortunately, that information needs to be captured from perhaps BIM models, from kind of the data, synthetic data that's coming in from design projects, rather than perhaps from existing structures. Although you could think about converting, let's say, point clouds and making meshes automatically and then deriving the graphs, and maybe that could be an option. So we focused on graph machine learning in Topologic as a way to incorporate AI in it. And we classify at the level of the graph, meaning, is this a hospital? Is this a library? Is this a prison? Is it a university building? And then we also do node classification. So is this a living room? Is it a bedroom? Is it a bathroom? And we also do linkage prediction. So should this conference room be connected to this breakout room next to it? So should there be a door or not? If the BIM model or the IFC model is missing that information, we can predict that. When it comes to LLMs, large language models, we believe that they will be useful once we can go from to have a conversation with your building, basically, and perhaps to generate it through a structured language. So basically, we've seen experiments, we haven't done them ourselves, but experiments where the language that is being created is actually the instructions for generating the building. And if that is accurate enough, it can be very powerful. It can save a lot of time to say, as Hyper has done, for example, saying, give me building with 3 stories and has an atrium and has this and that. And so you can use natural language and it can reply. But also, recently there has been research where graph-infused language models can give you better results. So in the sense that if you take a graph and you represent the building, you can start having a conversation about, is this conference room in a good location? Is it central or not? How long does it take to get out of the building in case of a fire, et cetera, et cetera. But you can have a more natural way of interacting with your design. And I think that could be really interesting.
Nice. Interesting. Anande, some questions from the audience?
So what I see from the questions a bit is that people are not sure what Topologic Pi is exactly. So it is a Python library, not?
Right. So yes, Topologic Pi is we call it an AI-powered spatial analysis software library. It's based on Python. It is built on Topologic, and Topologic is a C++ library for spatial analysis. So Topologic Pi is a Python binding on top of it, which allows you to just use Python to run it.
So you use it like any other Python library, So by coding, you use Topologic. And at the same time, you can integrate with all the Python ecosystem, so NumPy, Pandas, and all the other nice tools you have in Python, not?
100%. You just simply pip install Topologic Pi, and then you, in your Jupyter Notebook or your Python editor, you say import Topologic Pi, and then you can import NumPy, and you can import DGL in our case, or PyTorch, and you can use them all together. And that's what we do with our software. It's right now the best interface to it is just running it through either Blender or through a Jupyter Notebook, just scripting. If you are into scripting, you can definitely type it in.
Yeah, and that makes me curious, Wassim. Do you see like more and more architects are also getting into Python?
Definitely. Well, I trained them, so I have to say. So in our MSc, we are trained. So now it's in our 4th year, and we are absolutely graduating students who are not afraid to open up a Jupyter notebook and type in Python. And they do AI platforms, they do analysis platforms, really sophisticated stuff. So we are graduating tool builders rather than tool users.
Yeah.
And I think that's the way forward.
Yeah, because that's also something that I was wondering. How do you see these kind of technologies change the work of an architect?
Yeah, I mean, I think we are going to end up with, the early vision. I mean, obviously, I'm going to date myself a little bit, but the early pioneers of computer-aided design, etc., also always talked about it as design assistants.
Yeah.
And to have a true assistant that is intelligent, has intelligence, and has knowledge about what you're doing, and has context about what you are doing, is what we are aiming for.
Yeah.
And we are trying to reduce the friction. So once now, obviously you are typing a lot of Python scripts, etc. But even when I converted it to VIKTOR, all of a sudden I had to think about my software in a very different way, because I needed to peel away all that complexity and say, what would the user want to interact with on screen? They will want some sliders. They will want to upload a file. They want to see it as color coded. So I had to really focus on the user rather than as on a person that is just building on top of a foundation.
Yeah.
We have another question from Nikolai. So he asks, what does come first? A simplified topologic model, or do you produce it from a real 3D model?
Okay, so what's the first part of the question?
So what comes first? A simplified topologic model, or do you produce this model based on like a more detailed 3D model? I suppose that's the question.
So I'm not sure I understand the question 100%, but basically we're focusing on simplified conceptual models. We don't want to do a lot of detailed models and heavy geometrical models. But these models, so we sit, I sometimes tell my student, we sit somewhere between SketchUp and Revit. So we're somewhere in the middle, where the models are not dumb. They're not just simply geometry. They're really topologically very, very sophisticated. They know about things that are next to them. But it's always difficult to go from very complex real models down to topological models, because you need to simplify and peel away. But using AI, using shape grammars, you could go from simple models that represent the center lines and the center faces into fully detailed, fully kind of resolved BIM models.
Yeah, so maybe I think reflecting on the question, it's maybe, can Topologic work in both directions, not? So can you put a complex model and do like an analysis with Topologic?
Yeah, so I'll give you one example. Recently, we took a series of point clouds, and then we found Topologic can find the average surface. And by doing the average surface, even though they might be overshooting, we intersected and we came up with the cell, with the volume. So you can build a topologic cell, let's say, from a series of point clouds that might have a lot of noise in it, simply because you can build big surfaces, and then it will trim it for you and give you the correct volume that you are looking for. A lot of people, there's somebody who worked on something called BIM to BEM, which automatically looks at the interior faces of a BIM model, closes all the windows, creates the actual interior volume, and that becomes the volume that you would need for an energy model. So there has been some work on that going the other way, from complexity to kind of conceptual models.
Great. All right, Wassim, we have to round up. So thank you so much for this talk. It really changed my looking at architecture, I think, from this sort of more mathematical approach.
Sure.
It's really, really interesting to see. And maybe again, to also for everybody in the cloud, if you want to, you have a website, topologic.app.
Yeah.
So
yeah, topologic.app, or on GitHub, just look for my name and Topologic Pi, and pip install Topologic Pi is the easiest way to get it installed.
Great. And if you go to our website on VIKTOR.ai and go to the apps gallery, you can see, you can find the apps that you have made. So you can immediately just play around with them. So I can really recommend to do that.
Exactly. If you look up EnergyViz on VIKTOR, you'll find it and you can run it.
Great.
All right.
Thank you so much, Wassim.
Thank you. Have a good night. Bye-bye.
Thank you. All right. So for everybody, this was the ending of room 1. So we will now do a central closing in the plenary room. So yeah, we will leave this room now, and then yeah, if you'd like to see the closing, then please come to the plenary room. Thank you.
Yeah, thanks everyone.